Hey, welcome back. Today we are going to dive deep into an often overlooked but critical aspect of machine learning systems, data distribution shifts and monitoring. If you've been working with machine learning models, you know that just because your model performs well in the training phase, it doesn't mean it'll keep performing well in production. In fact, there are several pitfalls that can cause your model to fail once it's deployed, and today we're going to break them down. In traditional software systems, when something goes wrong, it's usually pretty clear. But with machine learning systems, failures are often much harder to detect and fix. Let's talk about three major ML specific issues that can lead to system failure. The first is production data differing from training data. Imagine you've trained your model on a clean, controlled data set, but when it hits production, the data starts to look different. This mismatch is a huge issue. Your model might be used to predicting based on features that no longer reflect the real world data it's encountering. This is one of the key reasons your model can suddenly start giving unreliable predictions after it's been deployed. Next, we have edge cases. These are those weird, unexpected inputs that your model hasn't been trained to handle. For example, your model might be great at predicting user behavior for most people, but what happens when a user behaves in an entirely unexpected way? Or think about rare events. Your model may not have seen these outliers in training, making it difficult for it to predict accurately when they occur in the real world. Finally, degenerate feedback loops can create a vicious cycle of declining performance. This happens when your model's predictions influence the data it gets, which then influences the model's predictions again. Imagine a recommendation system where the more users interact with the recommendations, the more the data is skewed toward those suggestions. Over time, the model can lose its diversity and relevance, amplifying biases or lowering overall accuracy. So, what happens when the data itself changes? This is where data distribution shifts come in. These shifts are changes in the statistical properties of the data over time, which can have a significant impact on your model's performance. Let's break down three major types of shifts you need to be aware of. First up, we have concept drift. This is when the relationship between inputs and outputs changes. In simpler terms, it's when the way your features relate to the target variable is no longer consistent. For example, imagine predicting stock prices. Past patterns might no longer hold true due to unforeseen economic events, and your model starts giving less accurate predictions. Next is covariate shift, where the distribution of the input data itself changes. This happens when the training data is artificially altered, such as by oversampling rare classes to make the model learn better. When the data in production doesn't match the distribution in training, your model might fail to recognize important patterns. Finally, we have label shift, where the distribution of outputs or the labels changes. Even if the model's inputs remain the same, the expected output might shift. For instance, imagine predicting customer churn. If the rate of churn changes drastically in production compared to the training set, the model might struggle to adapt. So, how do we keep track of all of this? This is where monitoring comes in. The goal of monitoring is to track the health of the ML system and detect issues like data shifts before they cause a problem. There are two key types of metrics to keep an eye on. First, operational metrics, which are your general software system metrics like latency, throughput, and CPU/memory usage. These tell you if your system is running smoothly from a technical standpoint. But what's just as important are ML specific metrics. These include things like accuracy, precision, and recall. These metrics help track how well the model is performing and whether it's still delivering reliable predictions in production. But the real challenge comes when data changes over time, and that's where things get tricky. Monitoring time series data requires advanced techniques, from time series analysis to detect shifts that might happen gradually. So you need to stay on top of how the model is performing over time. Now, let's talk about slicing. This is a powerful technique to understand how your model performs across different subsets of your data. You may find that your model works great for one group of users, but poorly for another. By slicing the data, you can identify those areas that need attention. You might be thinking, monitoring sounds great, but how do I really understand what's going on inside the system? That's where observability comes in. Observability is about getting more detailed insights into your system's inner workings. It lets you go beyond just looking at outputs and gives you a clearer picture of what's happening under the hood. For example, with observability, you could query your logs and ask questions like, show me all the users for which model A returned wrong predictions over the last hour, grouped by their zip codes, or show me the outliers from the last 10 minutes. This can help you detect issues before they turn into big problems. To make all this work, we need the right tools. Let's break them down. Logging is essential. You need to capture all the events and data generated by the system, including metadata, so that you can investigate later if something goes wrong. Dashboards give you a way to visualize your metrics and logs, making it easier to spot trends and issues at a glance. But be careful, too many metrics can overwhelm you. You need to select the right ones. Finally, alerts are essential for notifying you when something's off. An alert should include a clear description of what's happening, the time it was triggered, and the steps you can take to mitigate the issue. To sum up, ML systems are vulnerable to failures that can be hard to detect. Data distribution shifts, especially when they are not properly monitored, can have a huge impact on performance. But with effective monitoring and observability, you can catch these issues early. Remember, monitoring isn't just about keeping track of the model's performance. It's about understanding how the model is evolving and making sure it continues to perform reliably in the real world. If you found this video helpful, make sure to hit like and subscribe for more insights on machine learning and monitoring techniques. And remember, being proactive about monitoring and observability is key to maintaining a robust and reliable machine learning system. Catch you in the next one.